Welcome to Sleepy Stories. In this episode, we will take a clear and steady look at the nature of time within the universe, how it began, how it flows, and how every heartbeat and orbit is tied to its rhythm. The goal of this story is to help you learn while resting. If sleep doesn't come right away, that is completely fine. You can still absorb fascinating ideas about the structure of time and how it weaves through the cosmos. Simply listen. Let your breathing slow, and allow the information to settle at its own pace. If you enjoy relaxing stories that help you learn while winding down, feel free to like this video and subscribe to our channel for more journeys through science and calm reflection. Time feels so familiar that we rarely stop to ask what it truly is. We mark it with clocks, calendars, and seasons, believing it moves forward like a river. Yet in physics, time is not an external stream flowing past the universe. It is part of the universe itself. It began when the universe began. Before that first instant, there was no before. The birth of time was the birth of everything: space, matter, energy, and the laws that connect them. In the beginning, all was compressed into an unimaginably small point, a singular state where density and temperature defied comprehension. Then, expansion began. Space stretched, light separated, and temperature fell. In that act, the universe created its own clock, counting each moment through motion and change. Physicists describe this relationship through space-time, the union of space and time into a single continuum. Every object that exists, from galaxies to atoms, shapes this fabric through gravity and motion. When matter moves, time bends. When energy concentrates, time slows. This means there is no single rhythm beating across the cosmos. Every location has its own tempo. On Earth, we feel seconds and minutes as steady, but high above our planet. Aboard a satellite, time ticks a little faster because gravity's pull is weaker. Deep near massive stars, it runs slower. Each clock in the universe is telling its own version of history, yet all remain connected through the same physical laws. Imagine watching the universe in its infancy, a glowing sea of radiation filling expanding space. As matter condensed, new forms of order appeared, particles combining, atoms forming, stars igniting. Each transformation added new ways to mark time. The life of a star, from its birth in dust clouds to its eventual fading, could be seen as one long cosmic heartbeat. Galaxies rotated, gravity sculpted their shapes, and supernovae scattered elements into the dark. Over billions of years, time expressed itself not through numbers but through evolution, through change itself. Even now, when astronomers observe distant galaxies, they are not seeing them as they are, but as they were billions of years ago. Light takes time to travel, so every photon arriving at a telescope carries a message from the past. In that sense, the night sky is a time machine, a vast archive of cosmic memory. Looking deeper means looking earlier, closer to the moment when time and space first unfolded. Humanity eventually learned to measure these cycles, translating celestial motion into hours and years. Yet no matter how precise our instruments become, they remain echoes of the same principle that governs the universe. Change defines duration. Without change, there is no time. This realization ties the smallest vibration of an atom to the sweep of entire galaxies. Both are rhythms in the same grand symphony, each keeping time according to its scale. Understanding time also means accepting that it cannot be separated from us. Our perception stitches moments together, creating the sensation of flow. The ticking clock outside, the pulse in your wrist, the slow movement of your breath, all are expressions of the same universal rhythm that began nearly 14 billion years ago. The atoms in your body have kept that rhythm since the dawn of the cosmos. As you rest and listen, you are part of this immense unfolding. Every second passing here is linked to the expansion of the universe itself. Time within the universe is not something outside you. It is something you are made of, woven through every particle and thought. When you breathe in, the air carries atoms that have witnessed countless ages. When you exhale, you join them again to the wider flow. There is peace in knowing that even while you sleep, time continues its quiet, steady motion, the same motion that once set the stars in place. In the earliest moments of existence, time was not yet the gentle rhythm we experience. It began as a violent pulse within an expanding ocean of energy. In less than a trillionth of a second, the universe grew from smaller than an atom to larger than a galaxy. That sudden inflation smoothed space and cooled it enough for matter to appear. Quarks joined to form protons and neutrons. Within minutes, simple nuclei were born. Hydrogen, helium, traces of lithium. These were the universe's first stable patterns, and each represented a step in time's unfolding. Every transformation, every interaction, marked the progression from pure energy to structure. In this newborn cosmos there were no clocks, but there was sequence, an order of change that defined before and after. The radiation that filled the expanding universe acted as a kind of cosmic timer. As it cooled, it set the pace for all later history. About 380,000 years later, the temperature had dropped enough for atoms to form. For the first time, light could travel freely. That light still fills space today as the cosmic microwave background, a whisper from the dawn of time, bathing the universe in a faint glow of ancient heat. When scientists map that glow, they are looking at time itself frozen on a vast scale. The tiny variations in its temperature reveal the seeds of galaxies, the ripples of density that gravity would later sculpt into stars. Those patterns are more than relics. They are records of duration written across the sky. The waves of energy spreading outward are the silent memory of creation, proof that time has always been linked to change in matter and motion. As expansion continued, gravity began to gather the scattered gas into denser clumps. Clouds collapsed, heating from within until the first stars ignited. Their light filled the darkness, and the story of cosmic evolution truly began. Each star was a new kind of clock. Nuclear fusion deep inside their cores released energy at predictable rates, providing regular cycles that would last millions or billions of years. In those fiery hearts, heavier elements were forged: carbon, oxygen, iron, the building blocks of planets and of life itself. The story of time is therefore also the story of structure. Each step toward complexity created new ways for the universe to keep track of its own unfolding. Galaxies formed, rotating slowly as gravity-shaped spiral arms. The Milky Way itself completes one rotation roughly every 200 million years, a period beyond human comprehension, yet just another tick in the cosmic rhythm. The solar system condensed within one of those arms, and from that point forward, Earth's own revolutions around the Sun defined another scale of time. Even as the universe aged, expansion never stopped. The space between clusters of galaxies stretched farther apart, redshifting the light that travels through it. To astronomers, those stretched wavelengths are measurements of time's passage on the largest imaginable scale. Each faint beam arriving at our telescopes tells how long it has traveled, sometimes 10 or 12 billion years. In observing them, we witness a history written in color and distance. This understanding reshapes what we mean when we say, the universe is old. Age is not something added to space, but something born from its continuous motion. The past is the record of expansion. The future is the continuation of that stretch. Somewhere in that grand curve of history, a single planet cooled enough for oceans to shimmer and for awareness to arise, capable of wondering how long it has all been. When you think of the universe's beginning, imagine not a single explosion but a quiet blooming of possibility, an expansion that created both distance and duration. The seconds ticking now trace their lineage to that first unfolding. Time has been moving ever since, not as a river separate from creation, but as the very pattern by which creation continues. The understanding of time changed forever when Albert Einstein reimagined the universe as a single fabric, space and time woven together. Before his insights, people believed that time flowed evenly everywhere, unaffected by motion or gravity. Clocks were thought to measure something absolute, the same in every corner of the cosmos. But Einstein revealed a deeper truth. Time is flexible, its rhythm shaped by energy, motion, and mass. It does not merely tick forward, It bends, stretches, and folds within the geometry of space-time itself. To visualize this, imagine the universe as a vast, invisible sheet. Every planet, star, and galaxy sits upon it, curving the surface ever so slightly under its weight. Where the curve deepens, time slows. This means that near a massive object, such as Earth or the Sun, seconds pass more slowly than in regions of emptier space. The difference is almost imperceptible to us but measurable with precision instruments. High above Earth, in orbit, clocks aboard satellites tick a fraction faster than those on the ground. Without compensating for this effect, the navigation systems guiding airplanes, ships, and phones would drift miles off course each day. This is not science fiction, it is reality. Time is not a constant background rhythm but part of the dynamic structure of the universe. Every moment of your life unfolds along a personal path in space-time, a four-dimensional trajectory called a world line. The speed at which you move and the strength of the gravity around you determine how your own time compares to others. Even a person standing on a mountain ages slightly faster than someone at sea level, because gravity's pull weakens with height. These differences are small but real, reminders that the passage of time depends on where you stand in the universe. Relativity also explains why nothing can move faster than light. Light always travels at the same speed, regardless of how fast its source moves. To preserve this rule, nature adjusts space and time. The faster an object moves, the more its clock slows compared to one at rest. Distance contracts in the direction of motion. What seems impossible to intuition is perfectly consistent in the mathematics of relativity. Space and time exchange flexibility to ensure that light's speed remains constant for all observers. Consider two astronauts. One travels far into space at nearly the speed of light, while the other remains on Earth. When the traveler returns, only a few years may have passed for her, but decades for her friend. This is not a trick of perception, it is how the universe keeps its accounts. Both astronauts have moved through space-time differently, following distinct paths whose lengths depend on velocity and gravity. Each has experienced time personally, according to their own frame of reference. The idea that time can differ from one observer to another might feel unsettling, but it also brings harmony to the cosmos. It ensures that the laws of physics hold true everywhere. What we call time is simply the measure of change along each world line, and relativity shows that all such measures are valid. There is no single, universal now stretching across space. Every point in the universe carries its own present, defined by its motion and environment. In everyday life, these variations are too small to notice, but they exist constantly. As you sit, the planet spins, moves around the sun, and drifts through the galaxy, carrying you on a curved path through space-time. Every breath, every thought, happens along that journey. When we look up at the night sky, the light from stars tells us not only where they are, but how time has behaved on its way to us. The glow we see is already ancient, delayed by the geometry of the cosmos. Einstein's discovery transformed time from a simple backdrop into an active participant. It is not merely the stage on which events occur, it is one of the performers, changing its tempo with every movement of matter and energy. Time within the universe is therefore not uniform, but alive, shaped by the very things it measures. If space and time are threads of the same fabric, then light is the loom that holds them together. It is the universal reference, the single quantity that never changes no matter who measures it. Whether a galaxy races away at incredible speed or stands still, light always travels through the vacuum at the same pace, nearly 300,000 kilometers per second. This constancy forces everything else to adjust. When something moves quickly through space, it must give up a little of its movement through time to keep the balance. The faster you go, the slower your own clock runs. This is not a limitation but a law of harmony built into the universe. Imagine two beams of light leaving opposite ends of a spaceship as it speeds forward. To an observer inside, both beams seem to reach the center simultaneously. To someone watching from outside, the ship has moved during that interval, so the light traveling forward must go farther. Yet both observers measure light at the same speed. The only way for this to be true is if time itself slows down for the person on the ship. Space contracts, time dilates, and reality remains consistent for everyone. Light, therefore, defines the tempo of existence. Every motion, every event, is synchronized to its rhythm. It sets a cosmic speed limit not by constraint but by geometry. Beyond it, time would have to stop altogether. At light speed, duration ceases to have meaning. All distances collapse into one. Photons experience no passage of time. From their perspective, they are born and absorbed in the same instant, even if billions of years pass for us in between. These effects are not limited to thought experiments. They have been measured in laboratories and confirmed by spacecraft. Particles called muons, created high in Earth's atmosphere, should decay almost instantly. Yet when moving near the speed of light, they survive much longer, reaching detectors on the ground because time for them has slowed. This extension of lifetime is relativity in action, a proof that motion bends the clock itself. Everyday life moves too slowly for such distortions to matter, but they remain part of the fabric we inhabit. Without them, the universe would be inconsistent, physics would fracture. Instead, nature adjusts continuously, ensuring that all observers, no matter how they move, describe the same physical laws. The smoothness we experience, seconds following one another, cause leading to effect, is the result of this cosmic negotiation between light, space, and time. To sense the beauty in this balance, imagine standing on a quiet hill at night, watching the stars. Each point of light represents a story that began long ago. Some of those photons have traveled for thousands of years to reach your eyes. During that journey, the universe expanded, galaxies drifted, and entire civilizations rose and fell on distant worlds, yet the speed of that light never changed. It crossed the growing distances without hesitation, preserving a memory of its origin. You are not just seeing the stars as they are, but as they once were, their images delayed by the geometry that binds all things together. This interplay between constancy and motion keeps the universe coherent. It means that time is not something imposed upon matter, but something matter and energy create together. The steady rhythm of light allows every event to find its place in the cosmic order. Each second you live, each rotation of Earth, each orbit of the Moon, all unfold according to the same fundamental rule that light enforces. The clocks we build, the memories we hold, and the changes we observe are all expressions of that rule. Through light, the universe measures itself. It is the messenger that links distance to duration, revealing that what we call time is simply the record of change, seen through its unwavering speed. In this way, light does not merely illuminate space, it illuminates time itself. Gravity, the quiet architect of the cosmos, is also the sculptor of time. It bends not only space but the rhythm of seconds themselves. The stronger the gravity, the slower time passes. This truth, first predicted by Einstein and later confirmed through experiment, means that the ticking of every clock depends on where it rests within a gravitational field. On the summit of a mountain, time flows ever so slightly faster than at sea level. In deep space, far from any mass, it runs faster still. The effect may seem invisible, but it governs the precision of our world. Satellites orbiting Earth, carrying the atomic clocks that make navigation possible, tick a fraction of a second more quickly than those on the ground. Engineers must correct for this difference so your position on a map remains true. Without this adjustment, your phone's coordinates would drift, and airplanes would veer off course. Every direction you receive, every path you follow, quietly depends on the physics of curved time. To understand why gravity slows time, imagine space-time as a flexible surface. A massive object like Earth presses into this surface, creating a gentle depression. The closer a clock lies to the center of that depression, the deeper it sits within curved space-time. For light or motion to climb out, it must work against gravity's pull, stretching the intervals between its ticks. Clocks higher up experience less curvature, so their seconds pass more swiftly. The geometry of the universe ensures that mass and time cannot be separated. Where matter gathers, time lingers. Around the most extreme masses, black holes, this effect becomes astonishing. As an object falls toward a black hole, an outside observer sees its motion slow, its light redden, and finally fade. From that distant viewpoint, it appears frozen on the edge forever. Yet for the falling object itself, time continues normally. It never feels any pause. The discrepancy is not illusion, but perspective. The two observers inhabit different gravitational landscapes, each with their own valid rhythm. What seems eternal to one is fleeting to another. These effects reveal that time is not universal, but local. Every planet, every orbit, every patch of empty space has its own pace. The universe is not a single ticking clock, but a vast collection of them, synchronized only by the laws that govern their behavior. When you look up at the sky, the starlight arriving at your eyes carries the imprint of this diversity. Some photons have climbed out of deep gravitational wells, slowed and stretched by their journey. Others have crossed the gentle curvature of interstellar space almost unchanged. The light we see is therefore a map not just of distance, but of time's different speeds. There is a quiet wonder in this realization. The same force that holds your feet to the ground also shapes the tempo of your existence. Gravity links you to the planet and to the entire cosmos, slowing your moments by imperceptible degrees as you move through its field. Without it, stars could not form, galaxies could not cohere, and time itself would have no texture. Standing beneath the open sky, it is possible to sense this connection. The pull that keeps mountains anchored and oceans steady also guides the rhythm of your heartbeat. Every second you live unfolds within gravity's gentle curvature, part of the same fabric that enfolds stars, planets, and light. The slowing of time near mass is not a distortion. It is the natural way the universe balances itself. And in that balance lies one of its most beautiful truths. Time and gravity are inseparable, two aspects of the same deep geometry that gives order to everything we know. When we step back from planets and stars to the scale of galaxies, time begins to show its vast unevenness. Every corner of the cosmos experiences its own history. Some regions are older in appearance because their light reaches us only after immense journeys. Others reveal events happening long ago, still on their way to our eyes. In this sense, the universe is not a single synchronized moment, but a layered panorama of different ages unfolding all at once. The night sky is therefore both present and past. The light from a nearby star might have taken just a few years to reach Earth, while the faint glow from a distant galaxy began its journey billions of years ago. Looking outward in space is also looking backward in time. What we see in the dark sky above is the story of time laid bare. Closer stars shimmering in the recent past, distant galaxies burning in ancient youth. The deeper astronomers peer into space, the earlier the epoch they uncover. This happens because the universe itself is stretching. The space between galaxies expands, carrying them apart. As it does, the light traveling through that space is stretched as well, its wavelength lengthening toward the red. This redshift is one of the main clues that time in the universe is not absolute. It means that the further light travels, the older it becomes, losing energy not because of friction or resistance, but because the very geometry of space has changed while it was in motion. Astronomers use this stretching as a kind of cosmic clock. By measuring how much a galaxy's light has been redshifted, they can calculate how long the light has been traveling and how far the universe has expanded since it left. Each observation adds another point to the timeline of creation, allowing scientists to reconstruct the rhythm of cosmic history. The pattern that emerges is clear and graceful. Time runs forward everywhere, yet its local pace depends on motion, distance, and gravity. From this perspective, the universe resembles a great symphony with parts playing at slightly different speeds. Galaxies near us move gently apart, while those farther away accelerate more rapidly. The result is not chaos, but harmony on a scale almost beyond imagination. Each region evolves according to its own conditions, yet all follow the same cosmic laws. The redshift we measure today is like the music of that expansion, soft, continuous, and ancient. For the listener, it may help to picture this cosmic rhythm as a slow breath. The universe inhales as it draws matter together into stars and galaxies, then exhales as space expands and carries them apart. We live in the middle of one of those long exhalations. The tempo is so vast that we notice it only through observation, not sensation. Still, every atom, every photon, participates in this grand movement. Because of that, time cannot be considered apart from the expansion of space. The very age of the universe, about 13.5 billion years, is measured through this motion. The galaxies are not traveling through space like ships through an ocean. Rather, space itself is stretching, and with it, every measure of time. The cosmic clock does not tick in seconds, but in distances of light, in the faint background glow that still carries the memory of its first moments. And so, when we look across the universe, we are seeing countless layers of time coexisting in a single view. The present is filled with the past, and the past is still arriving. Each point of light, each trace of color, is a moment long gone, yet newly visible. Time within the universe is not a uniform river but a vast sea of ripples, each wave carrying its own age across the expanding dark. At the heart of time's direction lies a simple, quiet principle called entropy. It is the tendency of energy to spread, of order to dissolve into disorder. Entropy gives time its arrow, pointing from the organized past toward the dispersed future. Without it, events could just as easily run backward. A shattered cup could reassemble. Smoke could gather back into a candle flame. The laws of motion themselves do not forbid such reversals, yet they never occur. The difference is entropy, an invisible rule ensuring that change always moves one way. In the early universe, entropy was low. Energy and matter were concentrated, temperature was uniform, and everything followed a kind of elegant simplicity. As the universe expanded, that perfection gave way to variety. Matter clumped, stars formed, and heat began to flow from hot regions to cold. Every transformation, from burning stars to melting ice, added to the total disorder. Yet, within that process, structure and life emerged. Paradoxically, the arrow of time that drives entropy also makes complexity possible. Without the movement from order to disorder, there would be no stars shining, no cells dividing, no thought forming. Entropy does not destroy meaning, it records it. Every change leaves a trace, a pattern of energy distribution that tells what has happened. A dying star imprints its history on the elements it casts into space. The warmth left by sunlight on your skin is a message that energy has moved, a mark of the universe's ongoing transformation. In this way, time's passage is the accumulation of such imprints, one after another, forever building the archive of existence. The idea that time's arrow emerges from entropy also explains why we remember the past but not the future. Memory, like any physical process, depends on the recording of information, and that recording requires irreversible change. When you remember, molecules shift, neurons strengthen connections, energy dissipates. The act itself increases entropy, anchoring your experience firmly in one direction. The past is full of traces, the future contains none yet. On cosmic scales, entropy drives the evolution of galaxies and stars. As fuel burns within a star, its core becomes denser and hotter until balance breaks. Eventually, gravity wins, and the star collapses or explodes, scattering heavier elements into the surrounding space. Each death enriches the galaxy, allowing new generations of stars and planets to form. The process is irreversible but creative, disorder feeding the growth of new forms. Even the background temperature of the universe reveals this steady drift toward equilibrium. In the distant past, space was bright and hot. Today, it glows faintly at just a few degrees above absolute zero. The difference is the universe's memory of its own cooling, the record of entropy increasing across billions of years. If someday expansion continues forever, the cosmos may reach a state where energy is perfectly spread out, and no change can occur. Time, as we know it, would lose its meaning in that quiet stillness. Yet we are far from that end. Stars still burn, planets still move, and life still organizes itself against the tide. Entropy ensures that the story keeps unfolding, each event making the next possible. It gives the universe direction, not despair, a sense of motion that allows everything to evolve. In every atom and every galaxy, this principle hums like a background rhythm. It tells the universe which way to go and gives us a sense of before and after. Time flows because energy spreads. And though that flow will one day lead everything back into quiet balance, for now it remains the heartbeat of creation itself. The universe keeps its own time through expansion. Each passing second is marked not by a ticking clock, but by the stretching of space itself. This expansion began when the universe was unimaginably hot and dense, and it has continued ever since, carrying galaxies apart in all directions. The pace of that expansion defines what cosmologists call cosmic time, a measure that applies not to any one location, but to the universe as a whole. In this sense, time and space are two aspects of the same unfolding, their growth inseparable. When astronomers observe distant galaxies, they use light as the measure of this ongoing expansion. The longer that light travels, the more its wavelength lengthens. This redshift acts as a cosmic timestamp, revealing how far space has stretched since the light began its journey. A galaxy whose light has doubled in wavelength has seen the universe double in size while that light was on its way. Every observation of redshift is therefore a glimpse not only into distance but into duration, the growing record of the universe's life. This grand clock has no hands, no sound, no visible dial. It keeps time through geometry, not through movement. The expanding distances between galaxies are like the marks on a stretching fabric, each widening interval telling us that time itself has advanced. Even though the galaxies are not racing through space, they appear to move apart because space between them is expanding. What we perceive as cosmic motion is really a change in the very stage upon which all motion occurs. The tempo of this expansion has not remained constant. In the early universe, gravity slowed it, as matter tried to pull everything back together. Later, a mysterious influence called dark energy began to accelerate it again. This acceleration means that the universe's growth is speeding up, and with it, the rhythm of cosmic time subtly changes. In far futures, galaxies beyond our local cluster may drift so far away that their light will never reach us again. The night sky will grow emptier, the distant past fading from view. But even that fading is part of time's pattern. The stretching of space preserves history within itself. Each photon of ancient light carries the signature of how the universe once was. When we study that light, we are reading the cosmic record, a ledger of expansion inscribed in the language of wavelength and energy. Through these measurements, scientists can trace the entire evolution of the cosmos, from its first luminous moments to the slow, silent dispersal of the far future. For those listening, it may be comforting to realize that we inhabit one particular instant in that vast unfolding, a moment when stars still shine, when galaxies still share their light. We are beings made of atoms forged in long-dead stars, now living in the luminous middle chapters of the universe's story. Though expansion continues endlessly, we exist precisely within the era where the cosmos is still visible and connected. Cosmic time flows everywhere, yet it feels still. The galaxies move apart without resistance, following the same quiet rhythm that began long ago. This flow is so gentle that only the patient work of observation reveals it. The calmness we sense when gazing into the night sky mirrors that same vast calm, an expansion steady and persistent, measured not in minutes but in distances between worlds. In the language of physics, this expansion is simple geometry, but in the language of wonder, it is something deeper, the universe breathing. Each widening gap between galaxies, each stretch of starlight, is the measure of time itself expanding, a slow exhalation that carries us all forward together through the stillness of the infinite. To measure time, humanity has always looked for constancy, something that repeats without fail. In the earliest days of civilization, this constancy was found in the movement of the sun, the moon, and the stars. But modern science has discovered rhythms far more precise than any in the sky. Deep within atoms and deep within the hearts of dying stars, nature keeps time with remarkable accuracy. These natural clocks connect the smallest scales of matter to the grandest structures in space, binding the universe's rhythm from microcosm to macrocosm. Atomic clocks are among humanity's finest tools for measuring time. They rely on the steady vibrations of atoms, often cesium or rubidium, which oscillate at incredibly consistent frequencies when exposed to certain energies. 1 second, by international definition, is based on exactly 9,192,631,770 of these atomic oscillations. This number is not arbitrary. It reflects the unchanging rhythm of nature itself. Every laboratory, satellite, and observatory in the world calibrates against this same pulse, ensuring that the passing of a second is identical everywhere on Earth, no matter the weather, the season, or the location. Yet even atomic precision is part of a larger cosmic symphony. In the depths of space, neutron stars, remnants of massive stars that exploded as supernovae, spin rapidly, sending beams of radiation sweeping across the cosmos. These objects, called pulsars, rotate with astonishing regularity. Some make hundreds of revolutions every second, maintaining their rhythm with greater stability than any human-built clock. When scientists monitor a pulsar's radio flashes, they are listening to a natural metronome forged by gravity and nuclear physics. By comparing the signals of pulsars to those of atomic clocks on Earth, researchers can test the universe's consistency. Even the smallest deviation in timing could reveal gravitational waves rippling through space or subtle shifts in the curvature of space-time. The fact that these signals align so precisely tells us something profound. The same physical laws govern the beating of atoms and the rotation of stars. Across all scales, time keeps a single logic, expressed through countless instruments. Every improvement in timekeeping has deepened humanity's understanding of the universe. Accurate clocks allow spacecraft to navigate, telescopes to track faint objects, and scientists to test the predictions of relativity. When a signal from a distant probe arrives slightly earlier or later than expected, that difference, measured in billionths of a second, can reveal how gravity has bent its path. Time measurement, therefore, is not just a human convenience, but a scientific lens through which we see the structure of reality itself. The connection between atomic vibrations and cosmic rotation shows that the fabric of time is both delicate and dependable. It stretches across every scale of existence, linking the whisper of an electron's oscillation to the roar of a neutron star's spin. The same mathematics that describe the frequency of a cesium atom also govern the energy of pulsars and the orbits of planets. There is an elegance in this unity, a sense that the universe organizes itself through rhythm and repetition. It is humbling to realize that the seconds ticking on your watch are kept true by atoms echoing the behavior of stars. The technology in your pocket, the satellites guiding your direction, and the scientists charting distant galaxies all rely on the same harmony. In every vibration, every pulse, and every measured interval, the universe is counting its own heartbeat. This precision reminds us that time, though elusive, is not chaotic. It is orderly and consistent across unimaginable distances. From the atomic to the cosmic, every beat of time arises from the same laws, the same equations that have guided the universe since its first light. The rhythm we measure is not ours alone. It belongs to everything that exists. Our sense of now feels absolute. We speak of the present as if it were shared, the same for everyone, stretching instantaneously across the world and beyond. Yet according to the laws of relativity, such a universal present does not exist. What is now for one observer may not be now for another. Time does not flow evenly through the cosmos. It bends and shifts, depending on motion and perspective. This idea, called the relativity of simultaneity, reveals that the universe is not synchronized but woven from countless local moments. To understand this, imagine a long train rushing across an open plain. Lightning strikes both ends at what seems to be the same instant. To an observer standing by the tracks, the flashes occur simultaneously. But for someone aboard the train, moving toward one flash and away from the other, the situation changes. The traveler meets one beam of light sooner than the other. Both perspectives are correct, even though they disagree. There is no absolute now linking them, only relative sequences shaped by motion. This principle extends to every scale of existence. Two observers moving differently through space will measure events in different orders. What seems simultaneous on Earth may occur at different times for someone traveling near the speed of light. These differences are not illusions but expressions of spacetime's geometry. The universe allows each observer to experience a self-consistent version of reality, even if those versions do not align perfectly with others. Time, then, is not a single thread weaving through all things, but a tapestry of countless threads, each belonging to its own frame of reference. At first, this concept feels disorienting. We prefer to imagine a single cosmic clock keeping everything in step, yet the absence of such a clock is what makes the universe harmonious. It means that the laws of physics apply everywhere, regardless of who measures them. Light's speed is constant, the equations remain the same, and reality adjusts itself so that every observer sees nature obeying the same rules. In that balance, order replaces chaos. Even in our daily lives, traces of this relativity are present, though imperceptible. The Earth rotates, orbits the Sun, and moves through the Milky Way, while the galaxy itself drifts within a larger cluster. Every motion alters the way time passes ever so slightly. Each of us carries a personal timeline through this dynamic environment, our seconds shaped by our position and velocity. We do not feel the difference, yet it defines our place in the grand geometry of existence. Astronomers use this understanding when they coordinate signals between satellites, telescopes, and deep space probes. If they ignored relativity, the data would fall out of sync by microseconds that accumulate into vast errors. Instead, they adjust each clock according to its motion and gravitational environment. In doing so, they create a harmony of precision, an agreement built not on universal time but on relative time reconciled through understanding. This realization also changes how we view the universe. The distant galaxies we see today are not as they are in our present moment, but as they were when their light first began its journey. Our now does not reach them, their now does not reach us. The cosmos is filled with regions forever separated by the limits of light and motion, each unfolding its own sequence of events. And yet, all of these moments coexist within the same vast structure, connected by the laws that bind space and time together. There is quiet beauty in this relativity of perspective. It shows that time is not a rigid frame but a living network, each observer contributing one strand to the universal weave. The present is not something we share everywhere but something we each carry within, shaped by the motion of the world around us. After exploring the vast geometry of time across the cosmos, the focus now shifts inward, to the small island of perception within every mind. For all the precision of physics, the time that most shapes our experience is not measured by clocks but by awareness. What we feel as time's flow is the brain's way of interpreting change. Neurons fire in patterns, signals move between regions of the brain, and sensory information is stitched together into a seamless sequence. From this internal choreography, the sensation of before and after emerges. Unlike the clocks that count equal intervals, the mind's perception of time stretches and compresses. When moments are full of novelty or emotion, the brain records more detail, making those moments seem longer in memory. Routine hours, by contrast, fade into uniformity, their smoothness compressing them into shorter spans when recalled later. This elasticity means that time as we live it bears little resemblance to time as physics defines it. It is an inner construct, dynamic, personal, and sometimes deeply subjective. The rhythm of consciousness depends on the body's internal machinery. Within the brain, tiny oscillations of electrical and chemical activity act as a kind of neural metronome. These rhythms help us coordinate motion, speech, and attention. They are also influenced by external cues, light, sound, temperature, that keep our internal sense of time in harmony with the environment. When those cues shift, our sense of duration shifts with them. A dark, quiet room can feel timeless. Bright movement can make minutes race. Scientists studying perception have found that the brain does not perceive time continuously but in brief snapshots, like frames of a film. Each frame is integrated into a flowing whole, giving the illusion of unbroken motion. This mechanism helps explain how we navigate the world without confusion, predicting change even before it happens. The brain's timing circuits ensure that what we experience as the present is actually a small window of the recent past, a constantly updated reconstruction that feels immediate but is always slightly delayed. This inner processing ties our experience of time to attention. When we focus closely, the world seems to slow. When we are distracted, time seems to vanish. The amount of information the brain processes changes the density of subjective time. This is why moments of danger or awe can feel suspended, each second filled with vivid clarity. The brain expands its awareness, taking in more data, stretching those moments in memory. Meanwhile, days filled with repetition leave fewer marks, making them appear to have passed too quickly. Despite its elasticity, perception follows certain biological limits. Our neurons can only process signals at specific rates, and our senses refresh themselves over characteristic intervals. These limits create a minimum perceptible duration, fractions of a second below which events blur together. In this way, biology defines its own quantum of time, distinct from the quantum intervals of physics, but just as fundamental to experience. Time in the mind, then, is a mirror of the universe's own diversity. Just as gravity and motion shape time differently across the cosmos, attention and emotion shape it differently within us. Each person carries a unique rhythm, a private measure of change shaped by memory, focus, and feeling. In quiet reflection, one might sense how these two domains, the physical and the psychological, intersect. The body, bound by biology, obeys the same laws that govern stars and atoms. The brain's pulses, its chemical clocks, its electrical waves, all move within the same space-time continuum. The seconds that define thought are born from the same universal fabric that bends around galaxies. To feel time pass is to participate in the universe's deepest rhythm, experienced not through instruments, but through the pulse of awareness itself. Long before atomic clocks and telescopes, time on Earth was already synchronized to a grand cosmic rhythm, the turning of the planet itself. Every dawn and dusk mark a rotation, and every revolution around the sun defines a year. Within these vast cycles, life evolved an inner sense of duration, the circadian rhythm that governs sleeping, waking, and countless biological processes. This rhythm is older than humanity, older than language. It is a memory written into the chemistry of life, linking every organism to the motion of the world around it. Inside the human brain, a cluster of cells called the suprachiasmatic nucleus acts as the body's master clock. It receives light through the eyes, translating brightness into timing signals. When sunlight strikes the retina in the morning, it resets this clock, aligning the body's cycles with the external day. Hormones begin to rise or fall in response. Cortisol wakes the body, melatonin prepares it for sleep as darkness returns. Even when people are cut off from natural light, their internal rhythm continues, running slightly longer than 24 hours before drifting, evidence that this clock is self-sustaining, fine-tuned by evolution to match the planet's spin. Every cell in the body contains its own timing mechanism, a network of genes that turn on and off in rhythmic patterns. These molecular oscillations govern metabolism, growth, and repair. The synchronization of these countless tiny clocks keeps the body in balance, ensuring that tissues cooperate harmoniously. When that coordination falters, through irregular sleep, artificial light, or jet lag, the sense of time's order dissolves. Fatigue, confusion, and disorientation follow, as if the internal world has slipped out of step with the external one. Animals, plants, and even bacteria follow similar cycles. Flowers open and close according to the sun's path. Birds migrate with the changing length of daylight. The coral reefs of the oceans release their eggs and sperm in perfect synchrony with the full moon. These patterns reveal that life does not merely exist within time. It listens to it, moves with it, and adjusts its pace to the turning of the earth. Human history has always been bound to this natural metronome. Ancient calendars tracked the moon's phases and the sun's journey across the sky. Farmers planted and harvested according to the seasons. Sailors navigated by the stars. and rituals marked solstices and equinoxes. Every culture has measured time through the movement of the heavens, transforming the planet's rotation into a living rhythm that shapes behavior, belief, and rest. Modern life often obscures this connection. Artificial light extends day into night, and digital timepieces slice the day into mechanical precision. Yet the body still responds to ancient cues: the warmth of morning light, the cool silence of nightfall, the quiet satisfaction of cycles that repeat predictably. Even when surrounded by technology, the cells of our body remember the planet's rhythm, continuing to turn with it in quiet loyalty. If one pauses to notice, this synchronization becomes a kind of harmony. The rising and setting sun, the pulse of the tides, the changing seasons, all move in slow agreement with our internal clocks. We may measure time with numbers, but we feel it through these natural patterns. The world's turning gives structure to rest, hunger, and thought, linking the rotation of Earth to the small motions within every cell. Time within the universe, at this scale, is intimate. It is not the vast geometry of space-time, nor the motion of distant galaxies, but the soft rhythm of life responding to cosmic movement. In the beating of a heart or the opening of a flower, the planet's rotation finds its echo. Every moment of sleep and waking is a quiet collaboration between the body and the world that carries it through space, a dialogue between biology and the turning sky. Though our biology gives structure to time, our minds give it texture. The same minute can feel endless in fear and fleeting in joy. What physics measures in uniform intervals, consciousness reshapes into elastic experience. The brain does not count seconds, it interprets change. This is why time stretches during moments of danger, contracts during delight, and dissolves entirely in states of deep focus or meditation. Our sense of duration is woven not from clocks but from emotion, attention, and memory. When the body senses threat, adrenaline sharpens perception, neurons fire faster, and awareness widens. In those instants, the mind gathers more information than usual, filling memory with dense detail. Later, when recalling the event, the richness of those memories makes the episode seem to have lasted longer than it really did. By contrast, during calm or routine moments, the brain records fewer details, and memory compresses them. Entire hours may blur together, giving the illusion that time has accelerated. This phenomenon explains why days of novelty seem long and years of repetition seem short. Emotion alters the internal rhythm of consciousness. Sadness can slow perception, each minute heavy with reflection. Happiness and laughter make time feel light, almost vanishing as the mind rides the rhythm of pleasure. Curiosity, love, anxiety, each state bends subjective time in its own way. The inner clock beats according to feeling, not precision, creating an experience of duration as variable as weather. Culture, too, influences perception. Societies structured around punctuality often experience time as scarce, something to manage and control. Others see it as abundant, flowing naturally, guiding life at the pace of conversation or season. Yet beneath these cultural habits lies the same biology, the same neural networks marking change, the same patterns of chemical oscillation. Whether hurried or slow, time's feeling emerges from identical physical processes within the brain. Even memory shapes the flow of time. The more memories we create in a period, the longer it feels in retrospect. Childhood seems vast because every day is filled with firsts. Adulthood, by contrast, seems to accelerate because novelty diminishes. This means that time's apparent speed is not constant. It depends on how much of life we truly notice. To experience more time, one need not add hours, only awareness. Meditation and deep rest reveal another side of this phenomenon. When the mind quiets, its constant counting and comparing slow down. Without the usual rush of thoughts, the distinction between moments blurs, and a sense of timelessness can arise. In such states, people often describe feeling both entirely present and detached from time's flow. The experience does not deny physics. It simply shows that the brain's internal measure of change can pause, giving a glimpse of how still time might feel if perception were perfectly calm. This pliability of time perception demonstrates that we live within multiple timelines at once. The physical one, governed by relativity and atomic oscillation, proceeds with unwavering precision. The psychological one, governed by awareness and emotion, dances in waves and ripples. They coexist, inseparable yet distinct, creating the human experience of reality, precise in measurement, fluid in meaning. Every heartbeat, every breath, every thought contributes to that personal rhythm. We feel time not as the universe measures it, but as the mind transforms it. And in that transformation lies something deeply human, the ability to shape experience from motion, to stretch moments of beauty, to soften moments of pain. Time, inside us, becomes more than dimension. It becomes story. And through that story, the physics of the universe finds its echo in feeling. Before humanity could define seconds or measure atomic oscillations, we learned to observe the heavens. The rising and setting of the sun, the return of the moon's phases, and the migration of stars across the night sky gave our ancestors their first sense of duration. Time began as a pattern of light and shadow, a rhythm written in the motion of the heavens. From those early observations, the foundations of calendars, rituals, and civilizations were built. Stone monuments across ancient landscapes still mark this early awareness. Circles of rock in Britain and Ireland align with solstices and equinoxes, recording the longest and shortest days of the year. In Egypt, the flooding of the Nile was predicted by the first rising of Sirius before dawn, connecting the rhythm of the river to the rhythm of the stars. The Mayans charted the complex motions of Venus, weaving celestial cycles into their understanding of agriculture and divinity. Across the world, the sky became a shared clock, guiding both survival and meaning. In these early systems, time was not linear but cyclical. Days followed nights, seasons followed seasons, and lives followed the path of birth, growth, decay, and renewal. The repetition of celestial events taught that time did not rush forward but returned in graceful loops. Planting and harvest, rain and drought, birth and death, all seemed part of a cosmic rhythm that repeated endlessly. For ancient people, to live in harmony with this rhythm was to live wisely, in step with the order of nature. Religions and myths mirrored this idea. The sun died each evening and was reborn at dawn. The moon vanished and returned. The stars circled back to familiar constellations. Even creation stories often began not with a moment of origin but with cycles of destruction and renewal, a reflection of how early minds perceived time as eternal recurrence rather than progression. As observation improved, measurement became more precise. Sundials carved from stone marked hours through shadows. Water clocks dripped at steady rates, translating flow into duration. These devices were not only practical but sacred. To control time was to align with the cosmos itself. Yet even as precision increased, the underlying philosophy remained cyclical. The idea of time as a wheel persisted for millennia, shaping festivals, architecture, and daily life. This way of living in time created a deep connection between humanity and the sky. The movements of celestial bodies were not distant mechanics but familiar companions, reminders that order existed beyond human affairs. The stars rose predictably, the sun returned, and the moon's face changed with quiet reliability. Time was visible, tangible, and alive. Even today, traces of this ancient awareness remain. We celebrate solstices and New Year's, mark birthdays and anniversaries, all reflections of our desire to locate ourselves within recurring patterns. The calendar on a wall or the alarm on a phone may seem modern, but they echo the same purpose as the shadows cast by early monuments, to find structure in the passing of light and darkness. These traditions remind us that the measurement of time began not as control, but as communion. Our ancestors looked upward and found order in the heavens, comforted by repetition and the return of the familiar. They understood instinctively what physics later confirmed, that motion and time are inseparable, and that the turning of the earth and the cycles of the stars give shape to our existence. Each sunrise and sunset we witness today is part of that same lineage of observation. The rhythm that guided the first farmers and builders still turns above us. Even as we measure time in nanoseconds, we remain children of the same cosmic clock, still tracing its quiet circles across the sky. The story of time entered a new age when humanity learned to make it mechanical. For thousands of years, shadows and stars had ruled our sense of rhythm, but as cities grew and trade expanded, society needed precision that nature alone could not provide. Thus began the age of constructed time, an era when gears, pendulums, and later, oscillating crystals began to dictate the human day. The earliest mechanical clocks appeared in medieval Europe, driven by falling weights and controlled by simple escapements. They were often placed in church towers, their bells dividing the day into equal segments for prayer, labor, and rest. For the first time, time itself could be counted apart from celestial motion. It was a remarkable transformation. Time had become a human creation, no longer purely a gift of the heavens, but something that could be captured, divided, and regulated. In the 17th century, the invention of the pendulum clock brought extraordinary accuracy. The regular swing of the pendulum, tied to the pull of gravity, created a new standard of measurement. Hours became reliable, schedules became possible. This precision reshaped entire societies. Factories, schools, and transport systems all came to depend on it, and the experience of daily life changed forever. As technology advanced, so did timekeeping. Marine chronometers allowed sailors to navigate longitude with unprecedented accuracy, linking the measurement of time to the mapping of the world. Trains and telegraphs in the 19th century demanded synchronization across continents, leading to standardized time zones. The sun no longer ruled local noon, coordinated clocks did. Humanity had unified its sense of time across oceans, a feat unimaginable to earlier civilizations. Yet this triumph of precision came with subtle costs. The natural rhythm that once bound human life to daylight and season began to fade. Clocks introduced rigidity, shifts, deadlines, timetables. Where once there had been fluidity, time became something to manage, to optimize, to race against. The harmony between human activity and natural cycles gave way to efficiency and productivity. In many ways, the invention of the clock changed not only how we measured time but how we felt it. Still, the pursuit of accuracy revealed deeper truths about the universe. Each refinement in timekeeping forced scientists to understand motion and energy more precisely. Measuring the tiny discrepancies between clocks at different heights led to confirmation of gravitational time dilation. Observing atomic vibrations led to the redefinition of the second. Every improvement revealed that time was not uniform after all, but a dynamic quantity shaped by the conditions of space. Today, our instruments can measure intervals of time shorter than a billionth of a second. Atomic clocks aboard satellites correct for relativistic effects predicted by Einstein. Networked systems synchronize across the planet with astonishing precision, guiding global communication, navigation, and trade. We have reached an age when timekeeping borders on perfection. Yet the human relationship to time remains as complex as ever. Even in this era of atomic accuracy, we still sense time's mystery. No clock, no matter how precise, can explain why time flows or why it appears to move in one direction. The gears and frequencies reveal the structure of duration but not its essence. For all our mastery, we remain part of the same cosmic rhythm that ancient skywatchers once traced in the stars. As we listen to the hum of machines and the pulse of digital signals, we are still, at the deepest level, measuring change, the same universal phenomenon that began with the first expansion of the universe. Whether marked by the swing of a pendulum, the vibration of an atom, or the revolution of the earth, time remains what it has always been. The quiet unfolding of existence, one moment giving way to another, forever. Beyond the human scale, time stretches into immensities so vast that numbers alone can barely describe them. The lives of stars, the revolutions of galaxies, and the quiet transformations of matter unfold in epochs measured not by years, but by billions of years. Compared to such scales, a human lifetime is the faintest flicker. Yet within that flicker, we are able to glimpse and understand cycles that span the ages, uncovering how the cosmos itself measures the passage of time. Stars are natural clocks. They are born from collapsing clouds of gas and dust, mature into long-burning spheres of fusion, and eventually die, releasing their elements back into space. Their lifetimes depend on their mass. Massive stars blaze intensely but briefly, living only a few million years, while smaller stars like our Sun endure for billions. The fusion reactions in their cores tick forward at an astonishingly stable pace, giving the universe its own kind of heartbeat. By studying these processes, astronomers can estimate a star's age, reading its light like the pages of a chronicle. Our own Sun is halfway through its life, a calm and steady beacon in a galaxy of change. Around it, planets trace predictable paths, their orbits marking intervals so precise that they have guided human timekeeping for millennia. Yet even these stable patterns belong to larger motions. The Milky Way itself rotates once every 200 million years, pulling our solar system through spiral arms like a cosmic tide. Every rotation is a measure of galactic time, so slow that dozens of species may rise and vanish before a single turn completes. Beyond that, galaxies themselves drift through clusters, merging, colliding, and reforming. These processes play out over billions of years, reshaping the visible universe. The collisions are silent and stately, stars rarely touching but their gravity weaving new patterns. The light from these events often travels for eons before reaching us. To observe them is to witness time on a scale so immense that it erases the difference between past and present. Even larger structures, superclusters and cosmic filaments, evolve over incomprehensible durations. Gravity draws matter into vast webs, while expansion stretches them farther apart. On this scale, the entire universe seems to breathe, slowly contracting through gravitational attraction in some regions while expanding in others. Each motion marks another layer of time, another step in a dance that began with the Big Bang and may continue indefinitely. Humanity measures these enormous intervals with tools of reason and imagination. By reading the color and brightness of starlight, scientists can determine how long it has traveled and how the universe has changed along its path. In this way, astronomy becomes not just the study of space but the study of time, of how the universe tells its own story across vast distances and unimaginable durations. There is a quiet humility in recognizing our position within this scale. The years we live are tiny beside the lives of stars, yet they belong to the same continuum. The atoms in our bodies were forged in ancient stellar cores, their ages predating the solar system itself. Each breath, each heartbeat, carries material shaped by processes billions of years old. To exist at all is to participate in a timeline far older than memory. Time within the universe does not belong to one level of reality. It exists simultaneously in the flicker of a neuron, the rotation of a planet, and the slow fading of a galaxy. Across every scale, from microscopic to cosmic, the same laws apply. There is no boundary between human time and stellar time, only different measures of the same unfolding rhythm. If cosmic time feels vast and almost motionless, atomic time lives at the opposite extreme, so rapid and precise that its rhythm shapes the very structure of matter. Every atom, every vibration, every quantum transition keeps a form of time. The universe's smallest components do not simply exist. They oscillate, interact, and change in patterns that define the stability of everything built upon them. In this microscopic world, time becomes a series of discrete steps rather than a smooth flow, each event following the probabilities written into quantum law. At the heart of each atom, electrons orbit their nucleus not in continuous paths but in energy levels, jumping between them when they absorb or emit light. These jumps are instantaneous, each associated with a specific frequency of electromagnetic radiation. That frequency, repeating billions of times per second, is what gives atoms their ability to measure time with such extraordinary precision. The cesium atom, for instance, vibrates at a rhythm so stable that it defines the length of a second itself. What makes this rhythm special is its universality. Whether a cesium atom is on Earth, in orbit, or drifting in interstellar space, it will tick at the same frequency, apart from small shifts caused by motion or gravity. This consistency gives science an anchor, an unchanging pulse against which all other processes can be compared. Atomic time connects the behavior of the quantum world with the structure of space-time itself, tying human instruments to the geometry of the cosmos. In a sense, atoms are the smallest storytellers of time. Their vibrations are the language through which matter keeps track of change. These internal oscillations determine how molecules bond, how crystals grow, and how energy moves through materials. Every chemical reaction is a choreography of timing, atoms meeting and parting according to quantum probabilities that unfold in picoseconds, trillionths of a second. Just as stars shape the history of galaxies, atoms shape the history of everything smaller. Their constancy provides the baseline for all larger rhythms. Without stable atomic frequencies, light would not have consistent color, matter would not maintain form, and life could not coordinate the biochemical reactions that sustain it. Time at the atomic level is therefore not only measurable, it is essential. Quantum mechanics adds a strange twist to this idea. At the smallest scales, time seems to lose its strict continuity. Events are not neatly ordered but governed by probability. Particles can exist in superpositions, occupying several states at once, until interaction forces a definite outcome. This means that, at the most fundamental level, time might not progress in a simple line, but as a series of possibilities collapsing into reality. What we experience as smooth flow could be the brain's interpretation of countless quantum choices resolving every instant. Despite this uncertainty, the collective behavior of atoms forms a steady foundation. Countless fluctuations average out to produce the familiar regularity of macroscopic time. The seconds we measure and the hours we live are built on that quiet order arising from chaos. The harmony between microscopic unpredictability and large-scale stability reveals the balance that sustains the universe, one where randomness and precision coexist, creating the dependable rhythm of existence. It is astonishing to think that the watch on a wrist, or the clock that governs navigation satellites, draws its accuracy from the same principles that guide atomic transitions. Those tiny oscillations echo through every layer of matter, binding the universe in a shared rhythm that bridges quantum probability and cosmic gravity. From these vibrations emerges the continuity we call time, linking the smallest flicker of an electron to the slow turning of galaxies. Time within the universe, then, is not only vast but finely granular, composed of countless invisible beats, each a note in the quiet symphony of reality. Time leaves traces everywhere. Even when moments vanish, their effects remain woven into the structure of space. The universe, vast and seemingly silent, carries records of everything that has happened since its birth. These records are not written in ink or memory, but in radiation, gravity, and geometry. Every event that ever occurred left a subtle mark on the cosmic fabric, creating a history that can be read, even billions of years later, by those who know how to see it. One of the oldest such records is the cosmic microwave background, the faint afterglow of the universe's earliest light. It fills all of space, arriving from every direction with remarkable uniformity. This radiation began its journey about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light to travel freely. To detect it is to glimpse the moment when time, as we experience it, became visible. Each tiny fluctuation in its temperature tells a story of density and motion, the first hints of structure that would later grow into galaxies. When scientists study this background, they are reading the fossilized imprint of time itself, the preserved texture of the universe's youth. Gravitational waves provide another record, one that ripples rather than glows. These waves are distortions in space-time caused by cataclysmic events, colliding black holes, merging neutron stars, or even the echo of the Big Bang itself. Though incredibly faint, they travel unhindered across the cosmos, carrying with them a record of the movements that produced them. Detectors on Earth, sensitive enough to measure changes smaller than a proton's width, have captured these vibrations. Each detection is a message from a distant past, an event that may have occurred billions of years ago, still announcing itself through the tremor of space-time. In a more subtle sense, all light that reaches us is a message from the past. The color of a star's glow, the shape of a galaxy's spiral, the faint redshift of its spectrum, all encode how long the light has been traveling and how much the universe has changed since it began its journey. When astronomers study this light, they are not merely observing objects, but reading layers of time stacked upon one another. The deeper they look, the further back they peer, until their telescopes become windows into eras when galaxies were still forming and stars were just beginning to shine. The Earth itself carries a library of temporal evidence, in the layers of rock and ice, in the rings of trees, and in the isotopes of minerals. Time is recorded in patterns of decay and renewal. Each fossil, each layer of sediment, marks an era of the planet's transformation. The same radioactive decay that powers stars also provides the means to measure their age, revealing that the laws of timekeeping extend from the cosmic to the terrestrial without interruption. These records, gravitational, electromagnetic, geological, show that time is both transient and permanent. Moments pass, yet their signatures endure. Even after a star dies, its light continues to cross the void for ages, and its elements live on in new worlds. Nothing that happens is ever truly erased. It is absorbed into the ongoing structure of reality. To gaze at the universe, then, is to look not into empty space but into time itself, layer upon layer of memory, held in light and matter. The cosmos does not forget. It stores every pulse and vibration within its vast body. The glow of the background radiation, the tremor of a wave, the decay of a particle, all are echoes of time's unfolding. They remind us that the universe is both archive and storyteller, preserving the traces of its past while continually writing the next line in the endless record of its becoming. Among all the places where time reveals its strangeness, none compare to the edge of a black hole. Here, gravity grows so powerful that even light cannot escape. It bends space to the breaking point and stretches time to near stillness. The laws of physics remain intact, yet they take on forms almost unrecognizable. In these regions, the relationship between matter, energy, and time reaches its most extreme expression, a boundary where the familiar flow of moments dissolves into the geometry of the infinite. To imagine this, picture a star collapsing at the end of its life. As its fuel is exhausted, nothing remains to counter gravity's pull. The core implodes, crushing atoms and fusing matter into a singular point of unimaginable density. Around this point forms the event horizon, the boundary beyond which not even light can return. From far away, the collapsing star seems to slow, its glow fading and reddening as if frozen in time. To a distant observer, it never truly vanishes. It appears suspended, trapped on the edge forever. But for the matter itself, time continues normally. To the infalling particles, the final descent happens swiftly. They experience no pause or halt, no freezing of motion. The contradiction is one of perspective, not of law. From outside, time stretches toward infinity. From within, it rushes onward. Each observer's experience remains consistent, yet irreconcilable. This paradox is not illusion. It is a direct consequence of how space-time behaves under extreme curvature. Such distortions have measurable effects even far from black holes. When light passes near a massive object, its path bends and its frequency shifts. Clocks tick more slowly in strong gravitational fields. These predictions of relativity have been confirmed repeatedly, from the timing of satellites orbiting Earth to the light bending around distant galaxies. The universe obeys its geometry faithfully, no matter how strange the consequences appear to us. At the edge of a black hole, this geometry reaches perfection. Time's dilation becomes infinite. Distance loses ordinary meaning. If one could hover safely outside, they would see the universe beyond racing ahead, seconds turning into years, then centuries, then millennia. From that vantage, the rest of existence would appear to accelerate while one's own time slowed to near stillness. Inside the horizon, all paths lead inward, and the future itself points toward the singularity. These extreme conditions make black holes the ultimate laboratories for understanding time. They reveal that time is not an independent stream but part of the structure of space, elastic and responsive. What seems like destruction is, in truth, a demonstration of unity, matter and time collapsing together into a single curve. Even the light escaping from just outside the event horizon tells us stories about how time behaves near its limits, flashes stretched and slowed, carrying evidence of gravity's deep control over duration. Modern physics suggests that black holes may not erase information completely. The radiation they emit as they evaporate, a faint glow known as Hawking radiation, might carry the encoded record of everything that has fallen in. If true, then even at the threshold of oblivion, the universe keeps its memory intact. The information is transformed, not destroyed, woven back into the cosmic fabric. To contemplate this is to realize that time is not fragile but profound. It can be bent, stretched, nearly halted, yet it persists. Even where light dies, time continues its work, shaping, recording, and connecting. The universe allows no complete end, only transformation. In the silence near a black hole's horizon, where seconds extend into eternity, time shows both its resilience and its mystery. It is there, at the brink of darkness, that the flow of the universe reveals its deepest stillness. Beyond the brink of a black hole lies another frontier of time, neutron stars, the dense remnants left when smaller massive stars collapse. These objects are the weight of suns packed into spheres only a few kilometers wide, so dense that a single teaspoon of their matter would outweigh a mountain. Inside them, gravity presses matter into exotic forms, where the boundaries between particles blur and new states of matter emerge. Here, time and space are squeezed almost to breaking, and the laws that describe them approach their limits. A neutron star's gravity is immense, though not strong enough to create an event horizon. Yet it still bends space-time enough that clocks near its surface tick far slower than those far away. If you could somehow hover safely above one, a single second for you would stretch into several for an observer at a distance. Light escaping from its surface loses energy as it climbs away, its color shifted toward red, a visible sign of time's distortion. The entire object, spinning hundreds of times each second, becomes a clock of unimaginable precision. Many neutron stars emit beams of radiation that sweep across space like cosmic lighthouses, and these pulses arrive with astonishing regularity, providing scientists with some of the most stable natural timekeepers in existence. Inside these stars, matter is crushed into a sea of neutrons, stripped of the spaces that once separated atomic nuclei. The pressure is so high that normal concepts of structure break down. Physicists suspect that deeper within, neutrons themselves may dissolve into quarks, forming a dense soup that behaves according to rules not yet fully understood. In such environments, the distinction between space, time, and energy becomes delicate. Equations that describe ordinary physics begin to falter. It is in studying these extremes that we begin to approach the edge of known science. The behavior of time within these depths hints at a unification that might one day merge general relativity and quantum mechanics, a theory that could describe both the vast curvature of space-time and the tiny oscillations of particles within it. So far, no experiment has fully bridged that gap. Neutron stars and black holes stand as the universe's testing grounds, where our understanding of time and gravity is challenged most profoundly. From a distance, these objects appear eternal, rotating for millions or even billions of years, their slowing spins marking the gradual release of energy into the cosmos. Yet their stability is temporary. Over unimaginable spans of time, they will cool, fade, and eventually disappear, leaving behind only faint gravitational signatures. Even in their dying, they contribute to the great continuity of time, dispersing energy that will shape new stars and new systems. What these remnants reveal is that time, like matter, can reach states of tension and compression. It can flow slowly or almost stop. It can become inseparable from the structure of the things it touches. Near extreme gravity, time ceases to be something that simply passes. It becomes something that is defined by the conditions that shape it. For those who study the cosmos, this understanding brings both awe and humility. Every second experienced here on Earth is part of a spectrum that stretches from the swift flicker of atomic transitions to the deep pauses near singularities. There is no single universal tempo, only a harmony of different speeds, all part of one continuum. Time within the universe, seen through neutron stars and black holes, teaches that extremes are not contradictions but connections. The slowest moments and the fastest vibrations belong to the same fabric, unified by laws that we are only beginning to understand. And in recognizing this, we find a quiet truth, that every instant, no matter how fleeting or eternal, is a reflection of the same cosmic rhythm that began when the universe first learned to keep time. When we step back far enough, beyond stars, beyond galaxies, beyond even clusters of galaxies, a strange realization appears. The universe is not a collection of objects moving through time. It is time, unfolding in every direction. Each particle, each ray of light, each field of energy contributes to a single continuous fabric that is both space and duration together. This fabric does not need an external clock to mark its progress. It measures itself through change and through relation. The universe does not keep time, it is time, written across billions of interactions that occur everywhere at once. Physicists describe this view through the geometry of space-time. In this picture, the universe can be thought of as a vast four-dimensional structure, complete and whole. Every event, past, present, and future, exists as a coordinate within this structure. The ticking of clocks, the turning of planets, the unfolding of lives are simply slices through that totality. From our perspective within it, we experience a sequence of moments. But to the larger framework, all those moments already coexist. This idea, sometimes called the block universe, replaces the flowing river of time with a landscape, a static structure that contains everything that has ever happened and ever will. In such a picture, the future is not something that comes into being, but something already written, waiting for consciousness to arrive there. This is not destiny in the mystical sense, it is geometry. Time is not passing, it is arranged. Our perception of motion through it is the mind's way of reading the structure one layer at a time. This perspective may feel unsettling because it seems to challenge our sense of freedom and change, yet it does not deny the richness of experience, rather, it redefines it. The passage of time becomes a kind of traversal, not a creation. We are moving along the threads of a pre-existing design, yet within that movement lies everything that matters. Choice, awareness, emotion, discovery. The experience of now is not an illusion but a viewpoint, a cross-section of the larger whole. The block universe offers a kind of stillness that aligns strangely with reflection and rest. If all moments coexist, then the birth of stars and the quietness of tonight's sky are equally real, equally present within the grand structure. The arrow of time that we feel, driven by entropy and memory, is a direction within that structure, one of many ways to navigate it. We cannot move backward because our consciousness unfolds along one orientation, like a traveler following a single trail across a vast terrain. Some physicists and philosophers find beauty in this view because it erases the division between the living moment and cosmic eternity. The universe does not rush forward, it simply is. All events, from the first light to the distant future, form one complete pattern. Our awareness moves through that pattern, turning geometry into story. The feeling of flow arises not from time's passage but from consciousness illuminating one moment after another. In the stillness of this understanding lies an unexpected peace. If every moment exists eternally in its place within the universe's structure, then nothing is ever truly lost. The stars that have died still shine within the coordinate of their moment. The first atoms still vibrate within theirs. The past is not gone, it remains embedded in the architecture of space-time, like a page forever written in the book of the cosmos. To think of the universe in this way is to glimpse a deeper order. Time becomes neither enemy nor resource, but a dimension of existence that enfolds everything equally. The universe does not flow from beginning to end. It simply holds all beginnings and endings together, silent and complete, within its vast and eternal design. While relativity shows that time is a dimension intertwined with space, some physicists have proposed something even more radical, that time might not exist fundamentally at all. Beneath the familiar flow of seconds and minutes, beneath the expansion of the cosmos and the rhythm of biological life, there may be a timeless foundation, a reality where what we call time emerges only as an appearance, a property of relationships rather than a true substance. In the mathematics of quantum gravity, equations can describe the universe without referring to time at all. They present a reality where everything simply is, connected by correlations rather than sequences. In these models, what we perceive as temporal progression arises from the way parts of the universe interact. Change creates the illusion of duration. Time, then, is not an independent river flowing forward but a byproduct of comparison, a story told by matter about its own shifting configurations. This idea, known as emergent time, challenges intuition but finds echoes in experience. Imagine a still photograph of a waterfall. The picture itself does not move, yet within it are patterns that imply motion. Similarly, the universe may be static at its deepest level, with time appearing only when consciousness perceives differences between states. Our awareness, built to track change, converts those differences into what feels like flow. In such a framework, the past and future are not real in themselves, but reflections of correlation. The concept of before and after depends on memory, on systems capable of recording one state and comparing it with another. At the most fundamental level, without observers or processes to make such comparisons, the universe might simply exist as a complete whole, timeless and unchanging. The unfolding of events we experience would then be the mind's interpretation of an already complete reality. This view is not merely philosophical speculation. Some experiments in quantum physics hint at correlations that seem to defy a clear order of cause and effect. Particles can influence one another in ways that cannot be neatly arranged in time. In certain quantum circuits, the sequence of events becomes ambiguous, as though both orders occur simultaneously. These findings suggest that time's arrow may not be as absolute as once thought, that the notion of "this happened first" could dissolve under the scrutiny of the smallest scales. If time is emergent, then what we experience as history is a surface phenomenon, rising from an underlying symmetry that knows no distinction between past and future. The universe at that level would be like a timeless sea, perfectly balanced. Within that balance, ripples of correlation create the appearance of motion. We, as conscious beings, ride those ripples, experiencing them as moments. Though this concept may seem to erase the familiar comfort of time, it also reveals something profoundly harmonious. A timeless foundation implies that nothing is truly lost. If all configurations of the universe coexist within that deeper structure, then every event, every existence, persists in some form, woven into the fabric of the whole. What we call the passing of time could simply be our path through that unchanging totality. This interpretation does not contradict the laws of physics we observe. It reframes them. Relativity describes how time behaves once it exists. Quantum theory may describe how it arises at all. Between the two lies a mystery that continues to drive science forward, the search for a theory that unites the timeless with the temporal, the eternal with the fleeting. For now, we stand between both worlds, living in the motion of time while built from matter that may rest in timelessness. Whether time is fundamental or emergent, its presence allows the universe to be known, to evolve, and to reflect upon itself. In every sense, the illusion of time is no less real than the experience of being. If relativity reshaped our view of time across vast distances, quantum mechanics redefined it within the smallest domains. Here, time behaves not as a steady flow but as a backdrop, something that does not move but simply allows movement to be described. In the quantum world, particles do not follow predictable paths. They exist in probabilities, superpositions of all possible states, until an observation locks them into one. Between these possibilities, the familiar sequence of before and after begins to blur. Quantum theory treats time differently from all other variables. Position, momentum, energy, these can fluctuate and exchange, but time remains a fixed parameter in the equations, a stage upon which everything happens. Yet when we look closely, this division starts to falter. Quantum processes reveal that even the notion of sequence can lose its meaning. Two events may occur without any clear order, influencing one another as though causality itself is flexible. Consider the strange phenomenon known as entanglement. When two particles become linked, their properties remain connected, no matter how far apart they drift. A change in one is reflected instantly in the other, without any signal passing between them in time. The effect does not violate relativity, but it challenges the way we think about cause and effect. It suggests that at a deep level, the universe may not operate through linear chains of events. Instead, relationships exist outside the ordinary flow of time, forming a network of connections that simply is. This network view of reality blurs the distinction between time's passage and the structure of existence. If every particle carries information that correlates with others across the cosmos, then what we call the present moment could be the intersection of countless connections, each timeless in itself. Time's flow may emerge when those connections evolve into systems capable of memory and anticipation, creatures like us, whose awareness converts static correlation into dynamic experience. Even the act of measurement, the instant when possibility becomes reality, depends on time's peculiar status. Quantum mechanics allows particles to exist in superpositions, holding multiple states simultaneously. But observation collapses that superposition into one outcome. What determines when that collapse occurs? In the mathematics, there is no explicit moment. Time enters only when we impose it, when we record, compare, and define change. This suggests that time's direction might arise not from the equations of physics, but from the process of observation itself. Some physicists propose that time and consciousness may be intertwined at this level. The awareness that perceives change might also participate in creating the sense of change. Without observers to compare past and future, the universe could exist as a field of probabilities, complete but unexperienced. Observation does not merely reveal reality, it helps construct its sequence. The arrow of time may therefore emerge from the act of knowing, from the way information becomes structured through perception. This does not mean that time is a human invention, but that our experience of its motion is inseparable from participation in it. We do not stand outside time watching it unfold. We are part of the mechanism that gives it direction. The observer and the observed form a continuous loop, each defining the other. In this light, quantum mechanics does not abolish time but reframes it. The seconds ticking on a clock are the macroscopic echoes of quantum interactions happening everywhere, particles exchanging energy, collapsing from possibility into fact. What we call the present is the frontier where probabilities become reality, again and again, at scales too small to sense. The future is the sum of potential outcomes. The past is the record of resolved ones. Between them lies the now, forever renewing itself as the universe performs its endless act of observation. From the quantum to the cosmic, one interpretation unites both, the idea that all moments coexist. This view, known as the block universe, suggests that past, present, and future are not separate points moving through time but permanent regions within space-time itself. In this framework, time does not flow, it is already fully formed, every event fixed in a vast four-dimensional landscape. Our experience of movement through time is a matter of perception, like a traveler walking through a forest where all the trees already stand in place, though only one is visible at a time. In this conception, reality resembles a completed sculpture rather than a film still in progress. Every motion, thought, and heartbeat exists within its own coordinate, woven into a grand geometry that encompasses everything. The universe does not grow older, it simply is. We move through it along world lines, tracing our paths through this static structure, giving the illusion of sequence to something eternally complete. The mathematics of relativity supports this view. The equations do not single out a present or a universal now. They treat time as a dimension like space, with coordinates that can be mapped but not prioritized. Two observers moving differently will disagree about which events are simultaneous, yet both will be correct within their own frames. This symmetry implies that no moment holds privileged status. The Big Bang, the rise of life, the far future, all coexist within the same timeless geometry. Philosophically, This idea reshapes everything we think we know about existence. If the block universe is real, then nothing ever truly disappears. The past does not vanish. It remains embedded within space-time. The future is already there, waiting to be encountered by awareness moving forward along its path. Birth and death become coordinates rather than endpoints. Even the light of extinct stars continues to exist in its proper region, shining eternally within the geometry of its moment. To imagine this requires a shift in how we think about change. Instead of events being created and destroyed, they are simply revealed, like photographs developed one after another from a roll of film already exposed. Consciousness, then, might be the process of scanning this record, illuminating one frame at a time. Our sense of motion through time could be the unfolding of awareness across the dimension that already holds all possible experiences. Though abstract, the block universe provides a kind of peace. If every moment is fixed within the structure of reality, then nothing is ever lost. Every joy, every sorrow, every act of kindness or cruelty remains preserved in its place, unreachable perhaps, but never erased. The arrow of time that we feel, driven by memory and entropy, is simply the way consciousness moves across that landscape, always forward, never back, because memory itself points in that direction. The beauty of this idea lies in its quiet completeness. It transforms time from a fleeting current into a solid terrain, where every instant, from the first to the last, exists together in harmony. The cosmos becomes a timeless tapestry, its threads forming patterns that stretch across eons, each as real as the next. We inhabit only a narrow strip of this expanse, perceiving continuity where there is geometry, change where there is structure. If this vision is true, then the universe needs no future tense. Everything that will ever be already exists, suspended in the architecture of space-time. We are travelers walking through an eternal monument, carving meaning from our motion, turning geometry into story. And even as we move forward, the moments we leave behind remain forever alive within the silent, unchanging fabric of time. If the block universe suggests that all moments coexist, then the arrow we follow through it must arise from something else. That something is memory. Memory gives direction to experience, transforming static geometry into lived sequence. It allows the brain to distinguish between what has happened and what has not, creating the sensation of a flowing present. Without memory, the world would appear as a collage of disconnected impressions, with no sense of before or after. Time's passage, as we feel it, begins with the ability to remember. Memory is not merely psychological, it is physical. Every recollection is etched into the material of the brain through chemical and electrical change. Neurons strengthen or weaken their connections, forming patterns that preserve the trace of experience. Those patterns are irreversible. Once established, they cannot return to the exact state that preceded them. This irreversibility mirrors the laws of thermodynamics. Entropy increases, information accumulates, and the arrow of time points forward. In physics, entropy is the measure of disorder, but in consciousness, it becomes the measure of history. The brain's increasing complexity of connections parallels the universe's growth in entropy. Each moment leaves behind a trace, and those traces shape what comes next. The past exists as memory, both in neural networks and in physical reality itself, records of energy exchange, imprints in the fabric of matter. The future, by contrast, contains no such imprints. It is open, undefined, waiting to be shaped by what unfolds. Because of this asymmetry, we experience time as a one-way journey. We can look back through the traces left behind, photons of starlight, the strata of rocks, the neurons that fire when we recall a face. But we cannot look forward in the same way. The future holds no evidence yet, no structure to decode. Memory is therefore not just personal but universal. It is the mechanism by which the cosmos records its own history. Every photon, every grain of dust, carries within it some echo of what came before. The connection between memory and time also explains why emotion plays such a central role in our perception of duration. Moments charged with feeling imprint themselves more deeply, creating strong neural patterns that seem to stretch those moments in recollection. The more significant an event feels, the more of it the mind stores, and the longer it appears in retrospect. Thus, meaning itself affects the rate at which time is experienced. A dull hour may vanish, while a single vivid second can last forever in memory. At the cosmic scale, memory takes different forms. Stars carry the memory of their formation in their chemical makeup. Planets record their evolution in the layering of minerals and ice. The cosmic microwave background holds the memory of the universe's first light. Every structure we observe is an archive of change, a record of what time has already accomplished. Nothing is truly forgotten. It is only transformed into new arrangements of matter and energy. This understanding blurs the boundary between personal and universal history. The atoms that make up the human brain were forged in ancient stars. The same processes that burned hydrogen into helium billions of years ago now help generate the electrical impulses of thought. When we remember, the universe remembers through us. Consciousness becomes an extension of cosmic memory, organizing information in ever more refined ways. Time, then, may not simply move forward. It may accumulate. Each moment adds to the total record of existence. The arrow we follow is the growth of memory itself, both in minds and in matter. The universe is not erasing as it evolves, it is writing, and we, as beings capable of recollection, are among the instruments through which it keeps its chronicle alive. Life itself is one of time's most remarkable expressions. Every heartbeat, every breath, every act of growth or decay is shaped by the arrow of time. Living organisms do not merely exist within this arrow. They embody it. Evolution, metabolism, and memory all depend on processes that move irreversibly forward. Cells divide and age. DNA accumulates mutations, and species adapt through the steady filtering of generations. These transformations cannot run backward. Life, in all its diversity, is time's experiment in organization, a self-sustaining pattern of order resisting the inevitable drift toward disorder. The physics that drives stars also drives life. Energy flows from high concentration to low, from order to entropy, and living systems harness that flow to build structure. Plants capture photons from sunlight, ancient messengers of thermodynamic imbalance, and convert them into chemical bonds. Animals, in turn, release that stored energy through movement and heat. Every exchange marks the forward motion of time, an irreversible transformation from potential to history. Without entropy, nothing could change, and without change, life could not exist. Evolution is the grand narrative of this forward movement. Over billions of years, molecules assembled into cells, cells into multicellular organisms, and those organisms into ecosystems. Each adaptation was a response to previous conditions, a form of memory encoded in biology itself. The DNA carried by every creature is both a blueprint and an archive. Within its spirals lie the imprints of countless ancient struggles, the memory of survival and extinction. Time writes its story not only in stars but also in chromosomes. Yet life is not only a record of the past, it is a constant act of renewal. Cells rebuild themselves, tissues heal, and generations replace one another in an unending cycle. Within these cycles, however, lies direction. The repetition is never perfect. Each round carries subtle variations, and those variations accumulate, driving evolution forward. The arrow of time in biology is both repetition and transformation, like a melody that returns to its theme, but never in quite the same way. In the body, time operates at many scales. The heartbeat keeps rhythm in seconds, the sleep cycle repeats in hours. Growth, aging, and reproduction unfold across decades. On the molecular level, proteins fold in microseconds, and chemical reactions occur in trillionths of a second. These nested tempos form a hierarchy of biological clocks, all synchronized to the same cosmic principles that govern the orbits of planets and the decay of stars. Life is a web of timing, its existence depending on coordination across scales of duration. Even perception itself is bound to these rhythms. The neurons that fire, the hormones that rise and fall, the oscillations of brain waves, all operate within the flow of biological time. Consciousness could not emerge in a timeless world. It requires change, delay, and sequence. Awareness is the echo of the universe's first rhythms translated into thought. Through living beings, the cosmos has found a way to observe its own unfolding. At the scale of species and ecosystems, time gives rise to complexity. Forests age, oceans evolve, mountains erode, and new landscapes appear. Over ages, life adapts to each transformation, turning planetary change into biological opportunity. The story of evolution is the story of time creating resilience, the ability to change without breaking. Life reminds us that time is not only loss but also creation. Every moment that passes allows new patterns to form, new consciousness to emerge. The arrow that leads toward entropy also leads toward growth. Through life, time becomes visible, tangible, and self-aware. In every leaf opening to sunlight, in every heartbeat marking another second, the universe continues to learn what it means to change. When we look outward again, away from the brief spans of life and back toward the vastness of the cosmos, the same principle reappears. Every celestial body moves through its own timeline. Stars are born from the collapse of gas clouds, shine for eons, and then fade or explode, scattering their elements into the dark. Galaxies collide, merge, and reshape themselves. Even the most tranquil patch of space is in motion, filled with particles and light carrying memories of ancient transformations. Time at this scale is immense and patient, yet it follows the same arrow that guides the beating of a heart. Our galaxy, the Milky Way, has lived for more than 10 billion years. During that time, it has absorbed smaller galaxies and given birth to new generations of stars. The Sun itself was born in one of those stellar nurseries about 4.5 billion years ago, its light now sustaining countless forms of life on a small, rocky planet. But the atoms composing both the Sun and Earth are far older. They were forged in long-dead stars, giants that lived and died before our solar system existed. Their ashes became our soil, our oceans, our blood. When a star dies in a supernova, it releases more than light. It releases time itself. Heavy elements, carbon, oxygen, iron, gold, are flung across space, seeding the next generation of worlds. Each grain of dust that drifts between the stars carries the imprint of such an event, a record of the universe's ongoing renewal. When that dust gathers again into new suns and planets, the past becomes the material of the present. Time recycles itself, writing new futures from ancient remnants. On the grandest scales, galaxies also follow cycles. Some spin quietly for billions of years, while others interact violently, their spiral arms torn and remade by gravity. These collisions are slow dances lasting hundreds of millions of years. To us, they seem frozen, but to the universe they are moments of transformation, episodes in a narrative that stretches across cosmic epochs. Each interaction redistributes energy, creating new stars and new possibilities for life to emerge. The rhythm of creation and destruction continues everywhere. Clusters of galaxies drift apart as the universe expands, while within them, gravity gathers new structures. Stars ignite, planets form, and light begins its endless travel. The matter that makes you, the air you breathe, and the thoughts you think all trace their origins to these ancient processes. In this sense, time is not something happening around us, it is something happening through us. Human existence, when measured against this scale, seems fleeting. Yet brevity does not mean insignificance. Every human moment adds to the continuity of the cosmos. We are part of its ongoing expression, the means through which it becomes aware of itself. To look at the stars is to see the past. To think about them is to bring that past into the present. Consciousness folds the long history of matter into a single instant of understanding. Even galaxies, for all their grandeur, are transient. One day, the Milky Way will merge with its neighbor Andromeda, forming a new galaxy, larger, slower, and older. The stars will rearrange, the night sky will change, and time will continue. Nothing that exists in the universe is exempt from transformation, yet nothing truly disappears. The atoms, energy, and information endure, reshaped by each new phase of existence. In this endless cycle of creation, dissolution, and renewal, time reveals its most elegant truth: continuity through change. From dying stars to blooming life, from collapsing galaxies to the thought of a single observer, every moment is both an ending and a beginning. The universe moves forward by remembering itself, endlessly reassembling the pieces of its past into new patterns of light. When the scale of the cosmos is so vast that entire galaxies rise and fade like brief sparks, the human lifetime can seem impossibly small. Yet within this smallness lies something extraordinary. We are not separate from the universe's chronology, we are one of its expressions. The same laws that govern stars govern the beating of our hearts. The same unfolding that shapes galaxies also shapes the span of a single human life. Time, even when measured in the smallest increments of memory and emotion, belongs to the same continuum as cosmic evolution. To stand beneath the night sky and feel wonder is to experience this connection directly. The light that reaches your eyes tonight may have traveled for thousands or millions of years. In that instant of perception, two distant moments, one ancient, one now, coexist. You are seeing the past of another world and the present of your own, superimposed in one act of awareness. It is a quiet reminder that no boundary separates the observer from the observed. The same time that stretches between stars flows through you as breath and thought. Human life unfolds in a brief arc, but it is dense with transformation. We measure our existence not in billions of years, but in the subtle changes that fill our days: the growth of knowledge, the shifting of relationships, the deepening of understanding. Each of these is a form of time made personal. Just as galaxies evolve through collision and renewal, so do human beings evolve through experience and memory. The rhythms differ in duration but not in essence. This awareness gives new meaning to mortality. It reminds us that the end of a life is not an interruption in time's flow but part of its design. The atoms that make up a body do not vanish. They return to the cycle that has always sustained the universe. In decay, there is continuation. In loss, there is transformation. The same carbon that forms living cells today may millions of years from now glow as part of a star or drift in the atmosphere of another world. The brevity of existence sharpens its value. Knowing that our moments are limited makes each one radiant with significance. The awareness of time's finitude gives rise to art, compassion, curiosity, and love, the uniquely human ways of resisting impermanence. These are not escapes from time but celebrations of it, attempts to shape meaning within the movement of change. Through civilization and culture, humanity has learned to extend its presence beyond the lifespan of individuals. We record, remember, and imagine. We build monuments, write books, and send signals into space. These gestures are more than expressions of creativity. They are forms of continuity. They transform fleeting experience into something that endures, connecting one generation's present to another's future. Just as a star leaves light behind, each life leaves traces that travel forward through the fabric of time. And yet, even as we strive for permanence, there is peace in recognizing that impermanence is natural. The flow of time ensures that everything contributes to everything else. The boundaries between beginnings and endings blur when seen from the universal perspective. Every birth, every decay, every fleeting thought participates in the same ongoing transformation that animates the cosmos. To live with this understanding is to find harmony with change. It invites gratitude for the fragile present, awareness of the vast past, and calm acceptance of what will come. The rhythm that governs galaxies also governs hearts. The expansion of space mirrors the expansion of human understanding. We are brief, but we are integral. Our lives, though small in scale, are precise in placement, each a spark in the universe's continuing expression of time. After following the universe across scales, from galaxies to atoms, from birth to collapse, it becomes clear that time is not only movement but also stillness. Beneath all transformation lies a quiet stability, a kind of equilibrium that endures even as everything changes. This stillness is not the absence of time but its essence, the background against which every event unfolds. Just as silence gives shape to sound, stillness gives shape to motion. In its calm presence, the flow of existence finds meaning. For most of human life, time is experienced through motion, the ticking of a clock, the turn of the earth, the rhythm of a pulse. Yet there are moments when that motion seems to pause, when attention softens, when thought slows, when one becomes fully present. In those intervals, the sense of rushing forward fades, replaced by a profound awareness that everything is happening at once. The breath, the heartbeat, the whisper of wind, all align in a single, continuous moment. The past no longer presses, and the future has not yet arrived. Only being remains. These moments of stillness are not escapes from time, they are glimpses into its deeper structure. They reveal that motion and rest are not opposites but partners. The same laws that allow galaxies to spin also permit the space between them to remain quiet. The universe breathes not only through expansion and activity, but through balance. Within that balance, time holds itself steady, waiting for perception to catch up. In meditation, reflection, or simple silence, people often report a sensation that time has slowed or even disappeared. Science explains this as a change in brain activity, the loosening of internal clocks, the synchronization of rhythms within neural circuits. But beneath the biology lies something more fundamental, awareness aligning with the universe's natural rhythm. When consciousness ceases to divide moments into before and after, it begins to perceive the continuity that has always been there. The stillness felt within is the same stillness that underlies the stars. This stillness also exists in the grandest processes of nature. Between explosions and collisions, between cycles of creation and destruction, there are vast pauses. In the long interludes between supernovae, galaxies drift in quiet balance. Even black holes, for all their intensity, are surrounded by silence, fields of space where nothing stirs, where time itself seems to hesitate. The universe's drama depends upon these pauses. Without them, its rhythm would have no form. For human beings, stillness provides orientation. It allows thought to settle, emotion to calm, and perception to expand. In that state, one can sense the delicate fabric connecting all things. Time ceases to be an external force and becomes an atmosphere, something to inhabit rather than measure. The mind that rests in stillness is not escaping reality but entering more deeply into it, joining the universe in its quiet continuation. Through stillness, the arrow of time softens. It no longer feels like a current pushing us forward but like a field carrying us gently along. Every moment that has ever been seems contained within the present, accessible not through memory but through awareness. This recognition does not stop change, it illuminates its serenity. The ticking of seconds becomes less urgent, the boundaries between moments less sharp. One begins to understand that time is not a series of separate points but a single, continuous whole, calm beneath its surface motion. In that understanding lies peace. To sense stillness within the moving universe is to realize that time itself is never hurried. The stars turn, the galaxies drift, and life unfolds, but the foundation beneath it all remains unwavering. Stillness is time's true symmetry, the resting pulse of eternity, present everywhere, quietly reminding every conscious being that existence, in all its motion, is already complete. Time, as we have followed it, began with light and motion and extends endlessly into futures not yet reached. But if there is a truth that binds everything, from the earliest flicker of energy to this very moment, it is that time does not rush. It expands, it transforms, it carries all things forward with patience. In every corner of existence, from the smallest particle to the largest cluster of galaxies, time continues its steady work, shaping the universe while never hurrying it. The universe will keep unfolding long after the last stars fade. New structures will form from the remnants of old ones, and matter will continue to move through its endless cycles. Galaxies will drift farther apart, and starlight will stretch into wavelengths so long that space will grow dark and cold. Even then, time will not stop. It will remain the quiet framework within which everything rests, a dimension that holds all history and all possibility together. The rhythm that began with the first expansion will continue, slower perhaps, but never ending. For humanity, the awareness of time is both gift and burden. It gives meaning to change, yet reminds us of impermanence. We measure, remember, anticipate, and sometimes fear it. But in understanding its nature, we find calm. Time is not an enemy to outrun or a force to control. It is the field through which everything becomes real, the silent stage on which life, growth, and thought arise. When we learn to see ourselves not as separate from time but as part of its unfolding, a deeper peace emerges. Every heartbeat, every sunrise, every quiet breath becomes an expression of the same universal rhythm. If one looks closely, the distinction between motion and rest begins to fade. The atoms in our bodies vibrate with the same energy that fuels stars. The moments that seem to vanish never truly disappear. They remain within the universe's memory, embedded in the geometry of space-time. The people we have been, the things we have done, the light we have seen, all continue in some form, held within the great continuity that never breaks. Time does not take, it transforms. There is comfort in this continuity. The past is not gone, only distant. The future is not empty, only unseen. Every second of existence contributes to the grand completeness of the cosmos. When one pauses to sense it, to feel the quiet pulse beneath everything, it becomes clear that time itself is an act of balance, neither rushing nor resting fully, but unfolding in harmony with what it contains. And perhaps that is the universe's deepest lesson, that patience and presence are the same thing. To live within time is to belong to its rhythm, to participate in the great unfolding without resistance. Nothing in nature hurries, yet everything is accomplished. From the cooling of stars to the closing of a flower at dusk, all things follow the same law: change, renewal, continuity. So as the story draws to its close, imagine the universe as it truly is, vast, timeless in its completeness, yet alive in every instant. The galaxies continue to drift, the stars continue to burn, and within one small corner of space, consciousness watches and wonders. That wonder itself is time's greatest creation, the ability of the universe to reflect on its own duration, to find beauty in impermanence and stillness in change. May that awareness bring ease. As time carries you forward, know that you move within the same calm, steady rhythm that began at the dawn of existence. It has never faltered and never will. You are part of that continuity, an expression of the same unfolding harmony that holds all things together. We from Sleepy Stories wish you a good night.